Greetings, my little triglets. How is everybody today? Hope you're comfortable. All right, let's get this started here. So we're going to talk about section 5.7, and that has to do with inverse trig functions. All right, inverse trig functions are used when you have to find the angle. Usually we have, sine of 30 degrees is 1/2. Well, if I take the inverse sine, the inverse sine of 1/2, we should get 30. Okay, so it's just a way to find the angle when we don't have the angle. And we are given the sine or cosine or whatever trig function there is. Now let's talk about the sine wave here a little bit and what it looks like. So it looks kind of like that. It goes from 1 to -1. If I were to go in this direction, it would continue. Now, if I'm going to do the inverse, when you do inverse, you have points x and y. Well, the inverse, what happens is the y and the x switch places. So our inverse graph is a little more interesting. It goes like this, where this ending would be at -2 pi, and this would be at 2 pi. Okay, so that's the inverse of it. But the inverse, the green one, is not a function. And scientists don't like non-functions because you get many, many answers. They only want one answer. So to alleviate that problem, we're going to restrict the domain. We're going to only allow points to be put in between here and here. This is pi over 2, and this is -pi over 2. So that's our domain is restricted. That way, when we look at the green graph, it'll go from here to here. And that, from here to here, the blue is now considered a function because the vertical line test works. So our domain, we're going to say, is from -pi over 2 to pi over 2. And when you think about your circle, here's pi over 2, here's -pi over 2. So it's only from here to here. You may not go in these zones. These zones are the dead zones. Okay, those are dead faces. Okay, you don't even want to walk through there to get to an answer over here, because if you walk through there, you die. It's the dead zone. You got to remember that. So when you're trying to find the answers for the inverse sine, you need to go directly to it, either in the positive direction or negative direction, without going through. So if I said the answer was -pi over 3, that's in the same spot as 5 pi over 3. Now, which answer is correct? Well, this one I didn't walk through the dead zone to get there. This one, I walked on some landmines going through there, and now I can't do any math because I don't exist. What fun is that? All right, so you got to remember the difference here. We've got sine inverse is something you use to help find theta. That's different than 1 over sine. 1 over sine is cosecant, totally different. So be careful with that. Inverse helps you find the angle. 1 over sine, which is the reciprocal, helps you find cosecant. All right, so if I would draw that over here, I know I'm restricted on the right half of the circle for sine. For cosine, the inverse cosine, we're going to restrict it between 0 and pi. So for cosine, it's from 0 to pi. We can only have domain inputs from 0 to pi. So if I try to input 3 pi over 2, that's bad. You can't do it. And the reason they're choosing these domains is because, think of it, cosine's all positive here and negative here. Sine is positive here but negative here, so you're getting all the possibilities. These other quadrants, it just gets repeated in, so we don't need them. Okay, so Knowing that, let's do a few problems here. Let's take, what's the inverse sine of the sine of pi over 4? Okay, so let's think about just this right now. Sine of pi over 4, it's in the first quadrant. Hopefully you all know by now that that's root 2 over 2. Now it's saying what angle. When you see this, you got to say what angle, what theta goes with that. And because we're restricted on the right hand or the right side of this circle, the only one that's positive is, oops, I wrote pi over 2. That should be pi over 4. The only one that's positive is pi over 4. If you chose the one down here, it's negative pi over 4, and that doesn't make sense because we're not negative root 2 over 2. So it kind of looks like these two cancel each other out because you're getting that same answer. Well, that's only true if it's in the first quadrant to start with. If it's in a different quadrant to start with, then you're out of luck. Let me try one of those. Let's take the inverse sine of the sine of 5 pi over 3. Okay, the answer is not 5 pi over 3. First of all, that's the dead zone answer. Let's find 5 pi over 3. It's right here. Okay, so the sine of 5 pi over 3 is negative root 3 over 2. Then it's asking in the restricted zone, which is the right half, where is sine negative root 3 over 2? Well, it's still this same spot, but I don't call it this anymore. I call it negative pi over 3. Okay, so you just have to follow the rules and make sure you're picking the answers in the correct quadrants, in the correct restricted zone. Let's try another one. Let's look at inverse cosine of 0.6, and then I want to take the cosine of that. All right, well, inverse cosine of 0.6, what angle is that? Do I really need to know it? Is this, because remember, when we restricted the domain, the range always went from -1 to 1. Is this within that, in that zone here? It's between those two, so that means I'm in the first quadrant, so my answer is going to be 0.6. Now, if that doesn't make a lot of sense, what you can do is make 0.6 into a fraction, and now you know that this is x and this is r because it's the cosine of some angle. So if I draw positive 3 and 5, I don't really even need that, but I know it's 4. What's the cosine of this triangle? Well, it's still 3/5, so it's still 0.6. So you kind of go around in circles a little bit with some of these. Let's look at the next one here. If I have the cosine of the inverse cosine of 1.5, well, is that between -1 and 1? No, it's too big. So we don't have an answer here. Okay, so let me write a little summary here. That last part might have messed you up a little bit. So if I have sine and cosine, what you need to look for is if you have inverse sine, your answer has to be between negative pi over 2 and pi over 2. But if you have just sine, like this position, the last thing you're going to do is it just plain old sine, then your answer has to be between -1 and 1. If those happen, then your answer is what you started with. If those aren't happening, then it's going to be a little different. For cosine, if you have inverse cosine, your answer is supposed to be between 0 and pi. But if you have regular cosine, like we did here, for the last thing you're going to do, your answer should be between -1 and 1. If it's not, then you have an empty set. You have no solution. Okay? So you're not going to have to do anything with graphing with these. The graphs are a little bit crazy, but you do have to know the restrictions. All right, so let's look at tangent. So the inverse tangent has its restricted zone just like sine. Okay, but because tangent is sine over cosine, the restrictions are the same as sine. So it would be negative pi over 2 is less than or equal to x, less than or equal to pi over 2. As far as the 1 and negative 1, remember tangent doesn't have anything in the y direction restricted. It doesn't stop at 1 and negative 1, so there aren't any problems with that. So we just don't worry about it. So let's do an example. Let's say, what's the inverse tangent of 1? Okay, you might think it's on one of the corners because that's where we have our 1s and 0s. However, tangent of pi over 4 is sine over cosine of pi over 4. So that'd be root 2 over 2 over root 2 over 2, which reduces to 1. So you have to realize this is sine over cosine reduced. Okay, so pi over 4 would be the correct answer here. Okay, and if it was negative 1, if I have the inverse tangent of negative 1, then I'm going to be at negative pi over 4, not 7 pi over 4, because that's the dead zone. Okay, you'd have to go through it to get to the dead zone. All right, let me try one more tangent one, and then we'll talk about just using your calculator. So let's say I have the inverse tangent of negative root 3 over 3. All right, remember it's a combination of sine over cosine. And if it's negative, we're restricted to the right half of the circle. So negative means I'm in this quadrant somewhere. I don't know exactly where, but I just like to draw the triangle to tell me what quadrant I'm in. So if it's got a root 3 in it, it probably means you're either 60 or 30 degrees. So you're 1/2 and root 3 over 2, but the cosine or sine would be negative, or your root 3 over 2, negative 1/2. So either here or here. Well, which one of these will get me root 3 over 3? Well, I know from experience that this has to be on the top because then the 2's will cancel, left with 1 over root 3, which gets you root 3 over 3. So where does that happen? Where is this happening? You go over root 3 over 2 and down 1/2. So over root 3 over 2 and down 1/2, you're going to be here. This is the long side, root 3 over 2. This is the short side, 1/2. So your answer is not 11 pi over 6, it's negative pi over 6. You're just going one notch in the negative direction. All right, let me show you one more thing, and then we'll be done for the day. All right, let's say we're taking the cosine of the inverse sine of 4/5. Now remember, inverse with the negative 1 means you're trying to find the angle. So what do we know about sine? We know that sine is y over r. As soon as we start talking y's and r's and x's, you should be drawing a triangle. Right half is restricted for negative 1, the sine of negative 1, which is inverse. These are both positive, so that means I'm in the first quadrant. So y is 4, r is 5, that means x is 3. So do I need to know what this angle is specifically? Or can I find the cosine of that triangle that has the angle in it? I don't really need the theta. I just need to do the cosine, which is 3 over 5. So the cosine of all of that is 3/5. Okay. Well, I think that's all I have for you. So I will see you in class tomorrow. And don't forget, Trig loves you. Gotta love her back. Ta-ta for now.